Hello. So, this is the first class on our subject integrated circuits, MOSFETs, op amps and their applications. Now, I recall a very famous saying by Henry Ford. He said that coming together is beginning. So, using the NPTEL platform, we have come together to understand how this integrated circuits and MOSFETs and op amps can be used for various applications. Then he says staying together is a progress. So, I hope that my lectures are interesting to you, you find new things in those lectures and we stay together, we learn and that will be our progress. While working together is a success. So, when I give you some assignments, when I give you some homework, right, and you ask me questions if you have any doubts. So, you are working together, I am trying to teach you something, you are learning something, at the same time we are trying to exchange information in the form of assignments and homeworks and questions and answers, right. So, this is my goal, that at the end of this particular series you are able to understand how the integrated circuits, op amps as well as MOSFETs are fabricated. At the same time, what are their applications. Now, to start with, I have very interesting demo for you to start with this particular series. I have a tea in my hand. So, if you guys can see, of course, this mug you can see coffee written, but inside the mug there is tea, all right, and let me sip it and it is really delicious. So, the point is I know how to make a tea, right, and you probably would know how to make a tea as well. Those who do not know, let us see, right, what we need. We need milk, right, of course, some amount of water. We need some cardamoms, here are some cardamoms, all right, or we say elaichi. Then we have tea, and finally we have some sugar. Okay. These are the ingredients used to make this delicious tea. So, you will be confused why and how come this op amps, integrated circuits and MOSFETs and application has something to do with tea, right. The point that I am making today is a teacher will show you the ingredients. He will tell you, for example, let us talk about tea, right. What is this called? This is called milk, okay, cool. What is this called? It is called cardamom, nice. Tea, all right, sugar, okay. What to do with this? So, one time teacher will show you how to mix these things together to form a delicious cup of tea, and then you have to do it by yourself. Every time if you ask give me the cup of tea, it is called spoon feeding, is not it? Every time you want everything to be ready is not a correct approach in learning, right. So, whatever teacher tells us, whoever he is or whoever she is, right, listen the ingredients, listen the understand the topics, right. He will tell you these topics or these ingredients or these circuits or these components are used for this particular applications. Now, learn by yourself, spend time not only understanding what these lectures are all about, but also to understand how you can utilize this knowledge for different applications, right, and do not rely on spoon feeding. You should not rely on spoon feeding, you should be independent, all right, and you can get independent when you acquire knowledge. So, using this beautiful NPTEL platform, we start our first lecture, and the lecture is on integrated circuit technology, its introduction, right. So, you can see on the screen IC technology or introduction to IC technology. Now, before we start this particular presentation, I am sure that in your undergrad or in your 12th physics or in your masters, right, those who have studied electronics, instrumentation, applied physics, electrical engineering, mechanical engineering have came across discrete components. So, what are discrete components? Discrete components are a resistor. If you can please zoom in, this is a resistor in my hand. Let us see if we can see it. Okay. So, this is a resistor, all right, and everybody knows it, everyone knows it, this is what is a resistor. Okay. Now, let us see another component, this is a capacitor, right, capacitor, all right. Now, we have another component, we have diode, we have a diode, diode is anode and cathode, right. Now, finally, to show you, we have here integrated circuit or IC, right. This is what is an integrated circuit. What do you mean by integrated circuit now? So, when you integrate these components, passive devices, active devices, that is transistors are active devices, passive devices resistors, right, capacitors, right, inductors, these are passive devices. So, devices that does not require external power, passive devices, requires external power to drive, active devices. These devices, active and passive, integrated together on a small silicon chip and packaged. This forms your integrated circuit, all right. This is your IC. So, let us see what is an integrated circuit, what is the use of this particular integrated circuit and what are the kind of integrated circuit technology that are available. An integrated circuit, as you can see here, right, this particular section, this one is your IC, that is what I have shown you, right. This is your integrated circuit, and what is it? An integrated circuit is a miniaturized low cost electronic circuit consisting of active and passive components fabricated together on a substrate. So, what exactly substrate means? We will learn in the series what are the kind of substrates that are available, what are the kind of substrates that are used, and one of the substrate that is used in IC technology is silicon. That is why here in the definition I have written substrate in the bracket silicon. The active components like we discussed are nothing but diodes and transistors, while the passive components are resistors and capacitors. Now, what you see here, it is very interesting. You see this arrow, this one goes right to this particular chip, right, and this chip which is extremely small, this is a small chip of silicon, and within this chip there are thousands and thousands of transistors integrated with each other to form different kind of circuits. So, this particular chip, this silicon chip, right, how it is fabricated, and once it is fabricated, right, once it is fabricated, how it is connected to this external terminals. You see this, these are external terminals, how it is connected. So, here there is a connecting wires, if you see here there are connecting wires. These connecting wires, right, they are connected to this silicon chip and there are several techniques to take connection. One of the technique is called wire bonding, other technique is soldering, another technique is called metallization, and so on and so forth. So, when you make a silicon, or when you fabricate lot of transistors, lot of devices, lot of active and passive components integrated together on a small silicon chip similar to this, and then connect it to external world using this integrated circuit technology, where there are some connecting pins, where there are some connecting wires, and finally you use this casing for packaging the entire circuit. This whole thing will get us this particular device, and that is nothing but your integrated circuit, right. So, let us see the next slide. So, the first question that comes to our mind is, why we need this integrated circuit? What is the use of integrated circuit? We have discrete components, we can make different circuits, we can make PCBs, right. Why to go for integrated circuit, and is it really useful? So, let us say integrated circuits have several advantages. First is its miniaturization, that means it can be made extremely small, and when you make something really small, that means you can increase the equipment density. What does that mean? If I show you a silicon wafer, right, and within the silicon wafer if I can make 12 devices, or if I can make 56 devices, or if I make 108 devices, or if I make 1,000,000 devices, right, which will give you a better aspect. What is good for you? To have lot of components within a single chip, and that kind of having lot of components, lot of devices, transistors, diodes, resistors, capacitors on a single chip is possible using IC technology, and that is why it is extremely useful, because it can be miniaturized, and hence because of this miniaturization your equipment density would increase, alright. That is the main advantage of using IC technology. Now, what is the second advantage of using IC technology? Second advantage is batch processing resulting in cost reduction. What does that mean? That means that if I fabricate one resistor, alright, and I will show you in detail how you can fabricate a resistor, how you can fabricate a heater, how you can fabricate a MOSFET, right, and what are technologies behind used for this particular fabricating these devices. We will discuss in detail, but before we go to that particular set of lectures, let us understand what will happen when we fabricate one resistor, or if we fabricate 10 resistors. So, it is obvious that increasing the number of resistors, fabrication of resistors at one time will decrease the cost. That means that batch processing, number of devices produced in one batch is increased. Why increased? Because of its miniaturization. You can have millions of transistors on one silicon substrate. So, you can do batch processing, that means cost will come down, right. That is the second point that we discussed, which is batch processing resulting in cost reduction. Let us see the third advantage. Third advantage is improved system reliability due to elimination of shoulder joints. As you see in the first slide, what we have shown, there are no shoulder joints. So, when there are no shoulder joints, that means what? That means that your reliability would be better. How is it possible that without having shoulder joints or not having shoulder joints will improve reliability? Now, all of us has done basic electronics project in our undergrad studies, where we have done soldering, isn't it? Everyone knows soldering, and if you are not good in soldering, or even if you are good, you see that the solder, once you do it, it will come off. It is not reliable, right. Again it is not that soldering is not used, it is used, but for this particular application we do not require soldering at all, and if you remove soldering from the picture, then your reliability comes up, because you do not have to rely on these wires that we are soldering, because soldering has less reliability. So, we will see what kind of how we can take the context from the indicator circuit sometime later, but right now you understand that using the indicator circuits or why indicator circuits are important, because it has improved system reliability to due to the elimination of shoulder joints. What is our fourth point? The fourth point is better functional performance. Of course, it is better because you have millions of transistors on one device, you can have lot of circuits, you know, you can play with it, you can have op amps, we will see op amps itself has huge circuits made up of MOSFETs, and we will see that is why we have to understand MOSFETs, right. When we understand op amps, we understand MOSFETs, we understand MOSFETs, we understand indicator circuits, that is why everything is interrelated, right. But the point is where this indicator circuit will have a better performance or functional performance. Next is it has matched devices. Next is it is increased, or the devices with, that is indicator circuits, have increased operating speeds. Now of course it is important, right. What do you mean by operating speeds? How fast your device is, right. Would you go to the market and buy a phone that takes 2 minutes to start, or will you buy a phone that takes 5 seconds to start, or will you buy a phone that takes even smaller time to start? So, how a device works, how it can start, or it can restart or reset and restart, right. This everything depends on the circuit within it, and within a transistor how fast a transistor works, right, that depends on how we fabricate the transistor. There is a totally a separate series of lectures that are required to understand how we can change the switching speed, how we can change the drain to source, the length between drain and source, right, how you can change the gate, and how you can move from the traditional MOSFET to FinFETs and so on. So let us not worry about it. What we understand is that if you use integrated circuits, then your operating speeds can be higher, right. Now final point, it may not be final, that is what I started with giving you an example of a tea, right, that the things that I am telling you are the ingredients. You have to find, oh maybe masala is not there in the tea, isn't it? Same way there can be more advantage other than 7 listed on the screen. So reading is only way to gain more and more and more knowledge, right, and we should never stop learning. We should never stop learning, and when you never stop learning, when you learn something, when you read something, you understand, you put more things in your brain, you understand new topics, and the topics other than what is taught through lectures, through or from the professors. So it is very important to read other points other than what I will give it to you in this lecture. Okay. So the point 7 is the significant reduction in the power consumption. So when you see an integrated circuit, it will be it can be operated at way low power compared to the other circuits. So what we have discussed today, right now we have discussed why integrated circuits, and we have seen what is inside the integrated circuit. When I show you this IC, now you know that within this packaged device there is a silicon chip, and within the silicon chip there are transistors, and there are connections that comes out to these external pins. So now you know it is not so much difficult to understand what is within it, but this is just a crude way of understanding. So what if there is a silicon chip? So what if there is a transistor? How we can fabricate those transistors? That is what we have to learn, right. So anyway, let us go to the next topic, and that is based on the size, right, chip size, the ICs can be classified or integrated circuits can be classified. If it is between 3 to 30 gates per chip, it is called small scale integration or SSI. If it is 132 to 300, it is medium scale integration or MSI. If it is 300 to 3000 gates per chip, it is called large scale integration or LSI, and finally, if it is more than 3000, then we call it very large scale integration. Now, these are basic, okay, that there are ultra large scale and more, but let us not get confused. We see basic things which are repeating: low scale integration, rather it is small scale integration, it is medium scale integration, it is large scale integration, and it is very large scale integration. Okay. So, these are some of the ICs or a schematic that I have used in circuitstoday.com. This is a website from which I got this schematic. The idea is to use it and to show students what are the kind of ICs that you generally come across. The first IC on the left corner, that is this particular IC, is nothing but a metal can IC. So, when you see this particular thing, this is nothing but a metal cap, alright. So, this is called metal can IC or metal can integrated circuits. Then there is another one which is this one. This is ceramic flat pack integrated circuit. You can see it is a flat pack and it is a ceramic. So, now ceramic, silicon, glass, flexible substrate. So, this silicon or glass or ceramic or plastic, right, and you will come across lot of things that people use to fabricate several kind of devices. So, what is the base material that is used is called, the base material that is used to fabricate these devices is called substrate, alright. So, when you see the screen, it is written ceramic flat pack IC, that means ceramic is used for fabricating or used in fabricating this flat pack IC. Now, next one is your 14 pin dual inline package, it is also called DIP. Why 14 pin? Because there are 7 on one side, there are 7 on other side. We will see operational amplifier and then we will see more how these pins are related to what kind of functionality. Finally, on my the fourth chip on the screen, right, the bottom right, is 8 pin dual inline package, and again you see what is that, plastic, right, the plastic. Now, dual inline package plastic. So, what does that mean? And again you see here it is similar to what we have seen in the first slide. There is a silicon chip, there are connecting wires and there are terminal pins, right. So, when you come across this kind of different integrated circuit, do not get confused, they are all integrated circuits, it is only way they are fabricated or packaged. It can be metal package, it can be ceramic flat, it can be 14 pin, it can be more number of pins, it can be DIP, it can be DIP plastic, right. So, do not get confused with that terminologies, it is all integrated circuits. Okay. So, let us move to the next slide. What does this integrated circuit? So, basically integrated circuits we can divide into two parts, integrated circuits, right. We are dividing into two parts. Part number 1, it is linear integrated circuits, part second or the second part is digital integrated circuits. What are linear integrated circuits? Examples are operational amplifiers or op amps, and that we will study, right. What is linearity? Linear like this, linear. Now, digital integrated circuits, computer and logic circuits. This computers and logic circuits uses digital integrated circuits, okay. Computers and logic circuits, it uses digital integrated circuits. Now, as we see here, the relation between the input and output of a circuit is linear, of course, because that is why it is called linear integrated circuit, is not it. So, the relation should be linear. Relation between what? Between the input and the output, okay. While the second one, the circuit is either in on state or off state and not in between the two. That means that either it can be 1 or it can be 0, either it is on or it is off. That is what your digital circuit means, either it is on, that is 1, it is off, it is 0. Very easy to remember. You see, when we understand the concept, it is extremely easy to remember the things. Okay. So, let us go to the next slide. Now, we will see few techniques, right, or technologies that are used to fabricate this integrated circuit. The first one is monolithic integrated circuits. What is monolithic integrated circuits? Yeah, very interesting. You see, we divide this monolithic into two parts, all right. One is mono, means single, one, all right, and lithic. Lithic comes from the lithos. So, how we got this word? The word comes from Greek, all right. Monolithic comes from the Greek words, one is monos and second is lithos, that means single and stone. That means that if you carve a single stone to a sculpture, it is monolithic, all right. So, what do you think, why it is monolithic integrated circuit? That means that we are using a single structure, right, or single crystal to fabricate our integrated circuit, right. So, we have to use this silicon and we have to do lithography to form your integrated circuit. That is why mono and lithos, right, monos lithos, monolithography or monolithic integrated circuit, all right. So, the monolithic ICs refer to a single stone or a single crystal. Now, again confusing word, crystal. What does crystal mean? No, crystal is nothing, right? Crystal means just a silicon. You see here silicon, silicon. Don't worry. It's very easy. Okay. So, or a single crystal or single silicon, single crystal silicon. The single crystal here refers to a single silicon chip as the semiconductor material. Now, I am 100% sure that you guys know what is semiconductor, what is conductor, what is insulator. Thus, there may be few, and you see, don't worry if you don't know. If you don't know, that is why you have to attend the lectures. So, it is nothing wrong if you do not recall what is conductor, what is semiconductor, what is metal, all right. I will give you an example. Conductor will conduct electricity very well, billions of electrons, it is an ocean of electrons if you have studied somewhere, right. Very easy to pass electricity, to conduct electricity, conductor. Semiconductor, semi is half, right, or you say final, semi final, right. Semiconductor, that means it is possible to conduct electron with a particular parameters, right. We have to give some energy so that the electron will start conducting in semiconductor. What are examples of metal? Let us say any metal or conductor. What are examples of conductor? Any metal, right. Aluminum, gold, platinum, right. So, if you talk about the semiconductors, what are example? Silicon, germanium, very easy, right. Then you talk about intrinsic, extrinsic, that we will see, do not worry about it. What is intrinsic, what is extrinsic? Again you see, the idea is not only to help you guys or to help you to understand how the integrated circuits are fabricated or how the op amps are used or how the MOSFETs are used, but also to help you to refresh what you know, and that is very important. Always keep on refreshing what you know, what you have studied, very important. Okay. So, because it will be used in certain phase of your life, directly or indirectly. All right. So, where were we? We were on the semiconductor, and semiconductor we give example silicon and germanium. Nice, very good. Now we have insulator. What is insulator? That will not conduct, that will not conduct. What is an insulator? Wood is an insulator, you see, wood. So, my friends, I do not know from which phase of life or from which area you are watching this particular series, but I can give you an example which is kind of common. If you really think of, you may have seen a person, you know, getting shock because of the open wire and people hitting that person with a wood, is not it? Why they are hitting with a wood? Because wood is an insulator, wood will not conduct electricity, so simple, right. They do not know that it is an insulator, they know it will not conduct electricity, right, and we know it is called insulator, amazing. So, that is that semiconductor devices, electronics is very easy, right. Always take a real life examples, alright. Metal, what you see, right, how the current comes or how the power comes to your home through some wires, right. What are the wires made up of? Are they made up of copper? If copper, then it is a metal, that means it will conduct electricity, very easy, right. So, the point I am making here is that the single crystal in this monolithic integrated circuit is nothing but a silicon chip as a semiconductor material, and on top of this semiconductor material we are using all the passive and active components which are interconnected, right. Here see what we have read, the single crystal refers to a single silicon chip as the semiconductor material on which passive and active components are interconnected. Nice. Now, what is the advantage, right, or why monolithic ICs are considered as the best mode of manufacturing IC, as the best mode, alright. So, why they are considered best, what is there that they are considered best. So, let us see what is that they make it best. First is it can be made identical, that is really good, right. It is highly reliable, it can manufacture in bulk in very less time, and when it is manufactured in bulk in very less time, it will result in low cost. So, because of this parameter, it is considered, or monolithic ICs are considered as best mode for or mode of manufacturing, right. Let us see once again, it can be made identical, high reliability, it is manufactured in bulk in very less time, and finally it is low cost. So, this parameter together will together helps to make monolithic ICs to be the best mode of manufacturing. Now, let us go to the next slide. Everything that has advantages would also have some limitations, right. No one is spared, no one is spared in this world. So, if you have good qualities, there would be some bad qualities. Work on your good qualities, work on your bad qualities to reduce your bad qualities, right. But there are certain limitations that you cannot work on. And what are the limitations for monolithic integrated circuits? One, low power rating, that means it cannot be used for high power applications, and it can have power, or it can't have power rating of more than 1 watt, it cannot be used for high power applications. What is the next limitation? Isolation between components within the integrated circuit is poor. What is next one? Components such as inductor cannot be fabricated. What is next one? Passive components with the ICs will have a small value and external connection is required. What is next one? Flexible circuit is not possible. So, there are certain limitations associated with monolithic integrated circuits. So, what to do, right? And if there are some limitations, there are some solutions to overcome these limitations, right. So, we have to see another technology, right, which will overcome in some aspect these limitations, right, and this technology is nothing but thick or thin and thick film integrated circuit. You can call thick and thin, you can call thin and thick, does not matter. So, what are thin and thick film integrated circuits? These integrated circuits are larger than monolithic integrated circuits. First point that you have to remember is these integrated circuits are larger than monolithic integrated circuits, but at the same time they are smaller than the discrete circuits. Alright. So, thin and thick film integrated circuits larger than monolithic ICs, smaller than discrete circuits. Second point, it can be used in higher power applications. So, high power application it can be used. You see the limitations of monolithic ICs were they cannot be used for high power applications, while these circuits can be used. Cannot be integrated with diodes and transistors, right. Now, these are the limitations, right. So, first two are the advantages, other things are the limitations. Cannot be integrated with diodes and transistors, diode and transistor if required can be externally connected onto its corresponding pins. Finally, resistance and capacitors can be integrated. So, let us see what is thin film, what is thick film, and I will give you an example of both thin film and thick film integrated circuits. First, let us see the left side of the screen, and that is written the we have written thin film integrated circuit, right. So, fabricated by depositing thin films of conducting or semiconducting materials on the surface of glass or ceramic base. That does not mean that we cannot deposit film on silicon. We can deposit film on silicon, we can deposit film on silicon, we can deposit film on oxidized silicon, we can deposit thin films on glass, we can deposit thin films on ceramic base, we can deposit thin films on flexible substrates. That is what is called thin film integrated circuit. How the deposition is done, we will see. There are several techniques to deposit a metal film or a semiconductor film or a insulating film. All right. So, the point that I am making right now is that the thin film, why it is called thin film, because the thickness of the film is extremely small. So, here we have taken one example. What is an example? R equals to rho L by A. What is this? Very easy, right. What is R? Resistance. What is rho? Resistivity. What is L? Length. What is A? Area. Now, we all know this equation, is not it? So, can we make a resistor using thin film technology? And if yes, how? Can we change the resistivity? It is very easy, we change the material, right. But if you want to change the resistance, right, assuming that the material is same, then what you can do? You can either increase the length or you can decrease the area, is not it, because your equation is R equals to rho L by A. So, what does that mean? By controlling the thickness and width comes when there is an area. So, by controlling the thickness and width of the film, we can fabricate resistors of different values. Different material will have different resistivity. Similarly, capacitors. What does capacitor means? A simple definition of a capacitor is two plates separated by a dielectric or air, right. Dielectric is nothing but insulator. Okay. So, if I want to fabricate a capacitor, I can fabricate a capacitor by depositing an insulating film between two metal films, or in another way it is same thing. What is written? Capacitor can be fabricated by depositing two conductive film separated by an insulating layer or insulating layer between two conducting films, same thing, right. So, this is how we can fabricate a capacitor. We can also fabricate an inductor using thin film integrated circuit. So, these are some of the this is how the thin film integrated circuit can be fabricated. Now, let us see the thick film technology, and I will try to show you the actual device using the thin film technology that I have fabricated, so that you understand how it looks like. So, we move to this next section, which is our thick film integrated circuit. So, commonly this is also known as printed film circuits or screen printing or silk screen printing, right. It is obtained to it is used to obtain desired patterns, right, on the substrate. It can be ceramic substrate, it can be paper as well, right. So, I will give you an example. Okay. If you see what I have in my hand, what is this? These are the patterns. Of course, there is a wedding invitation, let us not consider this. Okay. So, let us see this one, alright. What do you see? There is an instrument right here, right, and there is a Ganesha pattern which is here, right, is not it? You can see it, instrument and a pattern. Now, how can you make these patterns? Do you know? Have you ever went to a screen printing shop, right? This is wedding card, right? Similarly, we kind of print lot of things using the screen printing technology, and this is thick film, because you can see, even you can, even if you touch, right, you will see the difference between the white paper and the pattern. There is some kind of step, right. Step is there because the film thickness is very large compared to thin film. So, what I am showing here is nothing but a thick film technology, and now here the material is nothing but it can be insulator, we do not need a conducting material here, is not it. But in case of integrated circuit technology, it can be a resistive material, it can be a dielectric material, it can be a conductive material with different properties, right. So, in this if you have seen, there is a screen that is used, right, with this pattern, and there is a ink that you can put, and there is a squeezy that you just splash it, or you just squeeze it across the silk screen, and below is your substrate. So, what will happen? Whatever the pattern is there, through that the ink will come down and it will stick on the substrate. You take it, you hit the substrate, and the pattern is there on your substrate. Substrate, right. Many times I have used this word substrate. What is it? It is silicon, it is glass, it is ceramic, it is plastic, it is the material on which you fabricate devices, right, that is your substrate. Now, you have seen this. So, what is the use of this screen printing? Screen printing, you can make quick sensors. If you have seen gas sensors, they are used using screen printing, because it is very easy to fabricate. You see, there is a manual screen printing, there is a semi automatic screen printing, there is a automatic screen printing, where you just keep on printing the patterns in bulk, right. When you keep on making the things in bulk, the cost will go down, alright. So, screen printing thick film technology uses the screen printing. Now, let us go to the advantage of thick film and thin film ICs, right, over the compared to monolithic ICs. First is it has better tolerance, you can control the thickness, right, better isolation between components, flexibility in circuit design, right. However, thin film or thick film can be used to fabricate active components, and it will further result in increased size. It is not that it cannot be used, but it will result in increase in size, right, because there are a lot of research papers that you may found, if you are interested in reading papers, that people use thin film technology to fabricate transistors. But if you want to fabricate millions and millions of transistors, you have to have lot of masks, right, because we will see what are masks again, right, and that will be in the following series, that you will understand how the IC is fabricated. The today's lecture is focused on what are ICs, what are IC technologies. So do not worry about it, right. When the time comes, you will know, right, and I will show it to you. Okay. So, let us go to the next slide. The next slide is hybrid or multi-chip integrated circuits. So, the integrated circuit is fabricated by interconnecting a number of individual chips, right. As you can see, the circuit is fabricated by interconnecting number of chips. Why? And this is the advantage actually. This is the circuit, the the interconnection of number of individual chip is the advantage of multi-chip integrated chips or circuits. This is used for high power audio amplifier applications. It is used for high power audio amplifier applications. You see, remember these points, okay? It is very important, because some suddenly if somebody asks you or question you that what is the advantage of hybrid or multi chip integrated circuits over monolithics, over thin film and thick film IC technology, you can quickly say first advantage is interconnecting number of individual chip. Second advantage is high power audio amplifier application, right. Third advantage is you can diffuse the transistor or diodes as the active components. Now, diffuse transistors or diodes can be made on this integrated circuit. Diffuse resistor or capacitor on single chip or thin film components can be of some of the passive components that can be fabricated, right. And finally, the metallized pattern or wiring is used for interconnection between the individual chip. That means that there are several advantages when you talk about hybrid multi chip integrated circuits. So, BJT, FET, how they are fabricated, how BJT is fabricated, how FET is fabricated, how MOSFETs are fabricated, we will see in the next class. All right. So, let us quickly recall what we learned today. First, we learn what is integrated circuit, why integrated circuit is important, right. How integrated circuits are divided into two main group. One is linear integrated circuits, second is digital integrated circuits. Linear integrated circuits example is operational amplifier. Digital integrated circuit example is computers or logic circuits. Linear integrated circuits works on linearity between input and output. Digital works on 1 and 0. Then we saw monolithic integrated circuit, right. Then we saw, so what is monolithic? Again, carving from a single stone, right, making or fabricating a device on a single silicon crystal, all right. Then we saw the advantages and disadvantages of monolithic integrated circuit technology. Then we saw thin film technology and thick film technology, and we understood that thin films can be used to the different materials can be used to deposit thin film on the different substrate. It can be glass, it can be ceramic, it can be plastic, it can be silicon, it can be oxidized silicon, it can be insulator on silicon, right. There is a word called SOI, silicon on insulator. So, we will see about that also. Then we saw thick film technology, we saw an example of a pattern, right. And now, if you go somewhere maybe in market, right, and you see there is a screen printing shop, just stop by there, talk with that guy, right, and you will see he has lot of time to talk with you, right. We do not go and talk, people have time to talk. So, try, go, listen, right, discussing with any person, always somehow you will learn something. Does not matter from whether he is an engineer or a scientist or a common man who has no degree, but he may have lot of experience. A guy working in a screen printing shop may have huge amount of experience than you will get sitting in a laboratory and doing a thick film technology, right. So, always remember, discussion, talking with people, understanding, sharing of ideas will improve your knowledge, all right. So, thick film, whenever you go to market, if you come across a screen printing shop, stop by, discuss, buy him a tea, right. Now, finally, we saw hybrid or multi chip integrated circuit technology, and then we saw advantages and disadvantages of all the technologies. In the next class, we will see the silicon. I will bring a wafer for you, so you can see how silicon substrate looks like. We will also see several techniques that are used to fabricate these integrated circuits. extremely interesting. I will give you an example at the end of this particular course. Like I said, technically, theoretically, you will have idea how things works, and when you go to a laboratory which is a facility to fabricate those devices, you will not get confused, you will not be blank, right. You know, okay, this is how it works. Oh, equipment is like this. This is the equipment used for depositing thin film. These are the equipment used for fabricating a MOSFET, right. But here you have to understand how it is fabricated, right, theoretically. Alright. So, I hope I see you in the next class, and we keep our journey on and we learn with every class, right. So, the last slide for this particular class, I will thank you all for attending this particular lecture, and it is a very famous saying by Swami Vivekananda ji, arise, awake and stop not until your goal is reached, right. Do not give up, right. Life is hard, but you should not give up. And of course, the second line we already discussed, and the final one, the key to success is action, and the essential in action is perseverance. So, it is always good to read other things apart from engineering, right. Try to read something, right, try to watch. In fact, I will tell you cool examples. You see, science fiction movies, there is a lot of fiction, right, but there is a lot of science. So, get the science part and enjoy the movie, right. See what they are showing, whether they are showing a thermal sensors, right, where you can see a person in night, how this thermal sensor would work. So, learn something from everything, right. When you see around, you have lot of things to learn. Alright guys. So, I will see you in the next class. Till then, you take care of yourself. Bye.